day 65. As I'm recording this right now, we are 2 minutes from Christmas vacation, which is always a fun time of year. So I hope you guys enjoy your break. This video should be pretty short, to the point, to help us get ready for class Monday, which is not in 3 days, but in, I don't know, a bunch of days. It's not like I know math. I can't count that far. Okay, but it's Monday, January 7th. Intro to definite integrals. Okay. The first half of the year is all about derivatives. The second half of the year is all about integrals. Now, we're going to learn about integrals in a couple of different ways. Okay. But the first way, when I ask you in class, what was the first thing I said about a definite integral? The first thing I'm going to tell you about it is a definite integral gives the area under the curve. Okay. So the definite integral gives us the area under the curve. Now, it's a pretty simple statement. It's a little bit more complex when we look at it a little bit more closely, because that area will depend on whether or not that area is above the x-axis or below the x-axis. Okay, so let's take a look at a function here. I'm just going to sketch some random function. So here's my function. This function is f of x. Okay. So let's go. Okay, so the first thing we need to know about a definite integral is what the symbol looks like. The symbol looks like it's a giant S. We'll talk about why it's a giant S early when we get back from break. Okay, but here's what it looks like. An integral sign looks like this. I'll put it in a different color so it stands out. It's like an elongated S. Okay, so that's the integral sign. What makes it a definite integral versus an indefinite integral is I'm going to have a little number on the bottom and a little number on the top. The bottom number in this case is going to be the number 0. The top number is 4. When I read this, right, when I read this symbol, I say the integral from 0 to 4. I always say it from the bottom number to the top number. Okay, we're used to going top to bottom, so this is a little bit backwards maybe for you. But we say, this would be said the integral from 0 to 4. So I want to do the integral from 0 to 4 of the function f of x dx. Okay. We always tack this dx on, or d, whatever the variable is, right? If it was the graph f of t, then I'd tack on, and then I'd say the integral from 0 to 4 of f of t dt. We'll talk more about where that comes from. We just need to always write it in every integral we do. One way you can think of it is we're integrating f of x with respect to x. It's a little bit more complex than that. Okay? So what this does is the answer to this problem, right? This definite integral, 0 to 4 of f of x dx, is going to equal the area between the curve and the x-axis. From x equals 0 to x equals 4. So really what that gives us is the area between the curve, right? This is f of x is the curve, and the x-axis right here. Okay? It gives that area from 0 to 4. Okay. Notice I stopped I started at 0 and I stopped at 4. The reason I started at 0 and I stopped at 4 because those were my limits of integration. Okay? Now you can see immediately why this was useful, right? If we want to calculate the area of different shapes, right, we know formulas for rectangles, triangles, trapezoids, things like that, parallelograms. But how do we find irregular looking shapes like this thing is? Okay? Well, definite integrals allow us to calculate areas of very bizarre shapes. Now, here's an important part. If the region shaded is above the x-axis, the area is counted as positive. So in the example I gave you here, I would get a positive number for this answer. Okay? So let's say the area of that shape is 12. Then the integral from 0 to 4 of f of x dx would equal exactly 12. Okay? If the region shaded is below the x-axis, the area is counted as negative. Okay? So, for example, let's say I have this graph. And let's say I know that the area of this region here, let's say I know the area is 18. Well, if I did, and this is f of x, if I did the integral from -1 to 4 of f of x dx, my answer would end up being -18. So the integral always counts if those regions, right? The integral would color in this region. But because that region is below the x-axis, the integral from -1 to 4 of f of x dx would equal -18. Okay? So it's important to keep in mind. All right. So let me just look at one example here. I told you I'd keep this short. Let's take a look at one example here. Let's say this collection of line segments right here is f of x, right? So this is the graph of f of x. I'm just going to ask a few questions, right, to see if we're kind of handling this idea. Okay? We're going to call this -1, we're going to call this +1, this +1, this -1. Okay, so my first question is, what is the integral from -5 to -1 of f of x dx? Okay. Well, see if you can figure that out on your own. We're doing the integral from -5 to -1 of f of x dx. So what do we think? Well, we know that a definite integral, right? We know it's an integral because of the big S. We know it's definite integral because it's got numbers on the bottom and on the top. That area is just the area under the curve, between the curve and the x-axis. So, and I'm starting at -5 and I'm finishing at -1. Well, it's simply that region right there. The answer to this question will be the area of that region. Now you may say, well, I don't know how to do an integral yet. Well, that's true, or it may be true, but get this. We can still calculate this because that area of that region is just a triangle, right? I can always calculate the area of a triangle. Well, what's the base of that triangle? Well, I see it's a distance of 1, 2, 3, 4, and it's a height of 1, 2, 3. So I can find the area of a triangle just by doing base times height divided by 2. So if the base is 4 and the height is 3, 4 times 3 is 12, divided by 2 is 6. The question is my answer positive 6 or negative 6? What do you think? If you said positive 6, you're correct, because that region is above the x-axis. I don't care about the negative signs on the limits of integration, the -5 and the -1. I care, is my region above the x-axis or below the x-axis? Well, here it's clearly above the x-axis. Therefore, the integral from -5 to -1 is 6. Okay? How about this? What is the integral from -1 to 3 of f of x dx? Let's pretend that goes right through that point right there. Well, the integral from -1 to -3 would simply be the area between the curve and the x-axis. Right there. Once again, it's another triangle, right? Well, that triangle has an area of what? Well, it's got a base of 1, 2, 3, 4. It's got a height of 1. 4 times 1 is 4, divided by 2 is 2. But again, I need to consider, is my answer going to be positive 2 or negative 2 here? Well, my answer would be negative 2 this time, because that region that I shaded is below the x-axis. Okay? All right, now here's an interesting question. I want you to see if you can figure this out. What would be the integral from -5 to 3? Well, that just spans the two regions that we did. Well, when we do this, let's just add up all the positive area, which would be 6. Subtract away the negative area of -2. 6 minus 2 is 4. So we get positive 4 as an answer here. Okay, my last question for you guys today. My last question is, what is the integral from -5 to 7 of f of x dx? Okay. Well, that's going to start at -5, and it's going to finish all the way out here at positive 7. Okay. Let me make sure that's actually 7. 1, 2, 3, 4, 5, 6. Oops, sorry, that's 6. Let's do this to 6. My bad. Well, again, when we're doing an integral, let's just look at all of these shapes. We already calculated that this area was 6. We already counted this area was 2, but it counted as negative, so it's -2. So let's figure out what is this going to represent. Well, again, I got a height of 1, 2, 3. I got a base of 1, 2, 3. 3 times 3 is 9. 9 divided by 2 is 9/2. Question is that 9/2 positive or is that 9/2 negative? Well, by now, hopefully you've caught on. That should be a positive 9/2, right? So I'm going to have to do 6 minus 2, which is 4. 4 plus 9/2. That would be 8 plus 9, which is 17. So we get an answer of 17/2. Okay. We'll look more at this kind of stuff on Monday. But what I want you to know right now, integral equals area under the curve. Have a great Christmas break. Enjoy relaxing. Enjoy, pick up a book from time to time. Read a book. And I'll see you guys Monday, January 7th. Have a great vacation. 2 Chains. Bye.